Yes, good morning to all. So today we are going to start a new topic, but before that, we'll take one of the example and then we'll go for the new topic. Okay, so one of the question that alpha beta unsaturated aldehyde and it is in the 5-membered ring compound. Okay, so we'll take that first example and then we'll go for the next topic. In this case, what happen? You are having such type of starting compound, that is a TM. So I will write this TM is like this one. This is a 5-membered ring compound, 5-membered ring compound. Okay, and there is a presence of pi bond, and here is a C double bond O and H. So it is your 5-membered ring compound. You have learned the Dickman reaction or intramolecular, that is the aldol condensation reaction. Aldol condensation reaction means when two molecules of aldehydes or ketone in which one of them have alpha hydrogen atom, when undergo reaction in the presence of alkali base, there is a formation of a beta hydroxy aldehyde or ketone, which on heating it undergo dehydration to give alpha beta unsaturated aldehyde. So this is your alpha beta unsaturated aldehyde. So this is your TM, that is the target molecule that you have to prepare. Okay. Now how to carry out its disconnection? Actually, firstly you have to go for the FGI, functional group interconversion. So firstly you have to write down the functional group interconversion. Here is a functional group interconversion. I write this as FGI, functional group interconversion. What is meant by FGI, functional group interconversion? When disconnection is not possible of the target molecule which contains functional group, then you can prepare that compound from the other compound. Means you have to convert that functional group into the another functional group. So it is called as a FGI or functional group interconversion. So this alpha beta unsaturated carbon compound we can prepare in the aldol condensation reaction starting from beta hydroxy aldehyde or ketone. So here you have to write corresponding beta hydroxy aldehyde or ketone. So here we have to write C double bond O and H, and here you have to add, already there is a H, already there is a H, here is already H, right? And the valency of the carbon is 4, 1, 2, 3, right? So if you add, that is the water molecule, then there is the addition of OH at beta carbon and addition of H at alpha carbon atom. So it is a beta hydroxy aldehyde, beta hydroxy aldehyde. Okay, so this further undergo disconnection, and you know it undergo disconnection when you are having a, that is the aldol condensation reaction. How to carry out this connection? You have to break in such a way that you should get corresponding possible fragments. Okay, so this beta hydroxy compound you can convert into in such a way that you must get corresponding possible fragment. How? This sigma bond open on this carbon, this C becomes negative and this C becomes positive. So this sigma bond will shift here and there is a formation of carbon-carbon double bond, right? So you get corresponding carbon-carbon double bond. Okay, so here we have to just carry out its a disconnection, and you can get corresponding fragment like this one. So just I will write down the same thing. Here is the C, here is the H. C becomes negative carbanion. The remaining part as it is C double bond OH. Here is also CS2, CS2. This C becomes double bond and here is a H, right? So in this way there is a formation of a carbon compound. So for this you can write corresponding compound that is called as a synthetic equivalent. So just you have to put here H. So just I will write same thing by putting only H. Okay, C double bond O and here is a H. Remaining part as it is. Remaining part as it is. So same thing we have taken, only we have decreased the number of the carbon atom. And here we have to write that is the H. So this is your H. It is your synthetic equivalent. This is your synthetic equivalent. Equivalent. This is your synthetic equivalent. So in this way you have to carry out it's a FGI and then you have to carry out it's a disconnection. Later on you have to write down corresponding a net reaction. So what is the net reaction? Net reaction you have to write in this way. Net reaction. A retrosynthetic analysis is the reverse of chemical reaction. Now in the reverse way you have to write down the formation of a TM, that is the target molecule. So here I will write the net reaction. Net reaction starting from this compound, that is the synthetic equivalent. So here you are having a such type of C, here is a H, here is also H, and here is your C double bond O and H. You can also write CS2, CS2 like this one. Okay, so it depends upon you. So either you write like that one or you can write like this one. Okay, so here is your C double bond O. C double bond O. First step is the formation of a carbanion. So the reaction takes place in the presence of alkali. You can take alkali, NaOH or KOH. It have ability to form the carbanion. So this carbon is acidic in nature. So this sigma bond open on this carbon. There's a formation of C negative and we can get corresponding, that is the carbanion. So in the reverse way you have to write down. Okay, so here is a C negative, here is a H, here is a C double bond O and here is a H. The remaining part as it is, C double bond O and H. Further, here the carbanion form, it will attack on the carbon of the second molecule. So this sigma bond open on this oxygen, O negative, C positive. So this negative will shift on this carbon, formation of a corresponding cyclic compound. So you get corresponding 5-membered ring compound, right? You get the 5-membered ring compound. Here is a C, here is the H, here is a C double bond O, H. This will like this one, C, here is O negative, here is a H, and this carbon will attack on this carbon. Means you get corresponding 5-membered ring compound. Further, it undergo protonation. O becomes negative and you can get such type of, just I will write like this one. Here is a O, here is a H, here is a H, here is a H, and here is a C double bond O and H. And when you hit it, then what happens? It undergo dehydration at 80 degree centigrade temperature. So how it undergo dehydration? Here, this OH is negative. So this sigma bond open on the oxygen, there is a removal of OH, carbon becomes positive. So this sigma bond will shift here formation of a double bond. There's a formation of carbon-carbon double bond, and you can get here such type of product. Such type of product. Formation of carbon-carbon double bond. Here is a C double bond O and H. So it is your TM, target molecule. It is your TM, target molecule. So in this case, what we can do? We can increase the number of carbon atom. If suppose if you increase one more carbon, it becomes that is a cyclohexane carbaldehyde. Means if you increase the size of ring, then also the same thing is there. So we have taken already the example which have the 6-membered ring. Now it is a 5-membered ring compound. Even though this H maybe also R. R means maybe CS3, and maybe CS3, maybe pH. So in this you have to write down the same mechanism. So firstly you have to write down the disconnection. After that you have to write down the net reaction. In this one, if you have any doubt, you may ask. Yes, any doubt in this case? In the retrosynthesis, we have taken near about 8 to 10 example, and if you prepare this 8 to 10 example, you can solve at least 2 example, and it is a compulsory. So we can solve that near about 2 example. So 4 plus 2 means we can get near about 6 marks on this retrosynthesis. So it is a very simple. You have to remember the some basic concept, and if you remember the basic concept, you have to write down disconnection and a net reaction. And here in this case, you are taking only those examples which you have taken already in the our syllabus. So in that way, the syllabus in the retrosynthesis is very, very simple. So retrosynthesis is a reverse of a chemical reaction in which you have to prepare the target molecule. So you have to break the TM, that is the target molecule, in a such a way that you can get corresponding possible fragments. Okay. So let me know if I have any doubt, you may ask. Okay, right. So in this way, we have completed this retrosynthesis. We have taken mostly all the examples, and even if you are not getting any example, you can also ask me. You can I will solve it, and I will post in your classroom. Okay. Try to solve those all questions in your textbook. Write down their definition and its retrosynthesis. Okay, so that we can prepare this topic. So you must attend all lectures, because we are going to solve maximum all questions itself in the class. So if you know the concept and how to solve it, because in this second term, mostly the questions are application based, means your concepts should be clear. If concepts are clear, then one can solve all the questions. Okay, so I think we should stop here on this retrosynthesis analysis. Okay.